So we are Shell Future Car. You may remember from previous presentations that one of our big deliverables is building a new bottom frame for the Eco Marathon car. But we want to start out talking about a different deliverable that we actually didn't mention during our alpha prototype, but is still very, very important for us. So I know all of us are very experienced with SolidWorks at this point. We've probably gotten pretty good at it. But something that at least any of us on this team haven't quite cracked yet is being able to collaborate well on SolidWorks. What we've done in the past is like emailing files and then you have to re-download, change the title, email back. And it's just kind of cumbersome. So one of our first deliverables we wanted to accomplish, not just for us, but for the Eco Marathon Club as a whole, was really nailing down a solution that allows for a more like cloud-based approach to SolidWorks collaboration. So a tool that we identified pretty early on was what you're seeing on the screen here. It's called 3D Experience. It's made by the same company that makes SolidWorks, so it's pretty well integrated, but it is its own separate tool. And it did turn out that Penn State had some licenses for this, but they just weren't utilizing them. So we were happy to be able to start doing some experimentation there and work through the download and start to identify the workflow here. So as you can see, this is the sort of the home screen on 3D Experience. The person who helped us get this set up was a little bit confused, thought we were the formula team, so it's misnamed currently as FSAE, but we're going to get that sorted out. So what we want to do today is just identify between Scott and I what like a mock collaboration would look like. So I've opened a SolidWorks file here. As you can see, I've only made a cube, right? This is a 1x1 cube, but just for the purposes of today, this is what we're going to work with. So I'm going to go up here to save the 3D experience, and we let it think for a little bit. Okay, so then I'm brought to this screen. So I will select a bookmark, which is like the 3D experience equivalent of the like file explorer that you see on your computer. So I've pre-made some bookmarks here. So within the 3D experience experimentation bookmark, we have a beta prototype test bookmark. So I'm going to save this part to that bookmark. So we're all squared away there. And then I'm going to click that and then save my file.
Eventually.
Yes, okay. So now I'm all saved, and now we're gonna flip over to Scott's computer and see what he can do with it.
Do you need to put it in work, that part?
I believe since the bookmark is in work, I think it should be good.
Cool. Alright, so we're gonna see how quickly this comes over. We had kind of a bunch of trials throughout the past week, and it was getting faster and faster, but that's also something that we need to work on, how long it takes to get the actual file. But it was coming through at a pretty solid rate as we were working on it. So bear with me as we wait for this file and then hopefully update it. Alright, so there's the file. So you just double click that, and then you go to open with more apps. It's a really convoluted process to get there, but then you have to go to the SolidWorks add-in. Alright, and then there's the cube. So if I go to the edit feature and make it bigger, go with 2, save that, and then go back to the 3D experience save. And then for some reason it makes you lock files and then unlock files to update the current version. So you have to make sure that you lock it and then check unlock files after saving. And then once you do that, it doesn't update right away as you would think. You would have to go back into 3D experience once you close this and click on the new revision button. So this was something that we were missing throughout the entire process. We were wondering why it wasn't updating on like the second end, because he would open a file on his computer and it would be the same thing, but we couldn't figure out why it wasn't changing because it would show in 3D Experience that it was different, like if you previewed it, but then when you open the file, nothing changed. So we figured out that you have to make a new revision for every single one, but I kind of like that because it keeps things kind of very ordered, and it just like goes A, B, C, D, E, F, and then just kind of keeps everything in line, which is pretty nice. Other than that, should you be good to open it back up?
Should be. Yeah.
Okay.
So then we will swap back to my computer. And again, it's not perfect speed. There is a slight latency here. Okay. All right, so that was pretty quick. So now we have revision B1. So I'm gonna open with more apps. And then we will open it with SolidWorks. Oh, that's on me. The first step that I neglected is to shut the old version down, which makes sense. So then we will try once more.
Nice. So now you have a bigger cube. As you can see, it's very minimal right now. We're hoping to work with more complex things in the future, but definitely something we want to try and pass on to future groups so that they can collaborate easier and make better parts for future cars. Yeah, so that's basically the 3D experience and what we've learned so far on that front.
And we've made a tutorial for future groups to go through the installation. That was something that took us a while to sort out. So we've documented that so that people in the future will have an easier time. So what we want to work with now, just like Scott was saying, is doing more complicated collaboration and just really hammering down what that workflow would look like on a real life project. So I'll turn it over to Ian for the CAD design.
Okay. Alright everyone, so to develop our new CAD model, we first had to examine the old one and look at the different things that we could improve on. So since the Eco Marathon competition is mostly about fuel efficiency in the urban concept car division, our main goal was to lower the weight of this past CAD model while still making it safe and stiff enough to hold the different forces that it will be subjected to. So regarding the weight, the current car frame, which I can pull up right now, is around 25 kilograms. Oh. Yeah, it's around 25 kilograms here, which we thought was good, but we wanted to make a goal for ourselves to lower that to 15 kilograms or even less, while still maintaining a safety factor between around 1.4, 1.7. So to do this, we went through the design, build, test process with through CAD, and Samira will describe that process now.
So before jumping right into making models in SolidWorks, we did a lot of brainstorming. We consulted with current club members and the instructor to come up with ideas and concepts for the design of the bottom frame. And at the beginning of the semester, we came up with this design, which was highly inspired by the current car's bottom frame. And the overall shape is like a box, but we did not want a box because it will limit the next team from building a body that is both aerodynamic and efficient. So considering that, the time frame of our project and ease of manufacturing, we decided to not go with this and go design a simpler one. So this was our second design. On this model, we decided not to build and design the vertical firewall that was up there. And this would help the next team make the body and the top frame as they see fit. And we also made the middle and the back components the same width to help make welding simpler. We were inspired by a past competition car that had narrow body but wider wheels to meet the requirements, dimensional requirements. And this would allow us to save weight, simplify our design, and help the next team to have a vision on how to improve the car. And after that, we optimized this design even more, trying to reduce weight and any unnecessary supports.
Yeah, so when we did the design, we kind of did a kind of a real life FEA with the tubing that we had and the tubing we had selected for the for that design, and we saw that the deflection was around 1.5 to 2 inches, which was really bad, and it was not what our FEA was saying that the deflection was. So after we did that, we decided to come up with different solutions and implement them into our CAD model to see how that would work. And the three main things that we wanted to do was to select tubing with larger moments of inertia, then decrease the wheelbase so that the unsupported area of the driver would sit on would be much shorter. And then also see if we could rely on the stiffness that the body would provide to lower that deflection. Since we kind of wanted to solve this problem as fast as we could, we kind of focused on the last two. And what we saw So what we did was we decreased the wheelbase and simplified our model much more, since our past model had a lot of different supports that we realized we didn't need at all based on looking at the current car, and then we were kind of over-engineering it a little bit. So we decreased the wheelbase and kind of simplified our model, decreased some supports, and we also kept similar idea kind of at the back. As you can see at the back of the of the frame, which is this part here. We have the main constraint, which is the, not the main constraint, one of the main constraints, which is the engine and the weight of the engine. And we estimated that to be around 40 pounds. And we basically just put horizontal supports where the engine was gonna sit at. We did not do supports going from one side to the other side in horizontal bars, since we thought this would just be kind of increasing the weight and increasing weight we did not need.
We gotta move this
Okay,
along.
sorry. So we looked at the main forces and we did some FEA and our displacement. Our displacement from the forces that we got, which were the main body of the body of the driver and then the engine, was around ½ an inch based on our simulated FEA. But now I think we're gonna go to the OLF to show you a little bit of a real life FEA and show you what the real deflection is, since we increased the moment of inertia of the middle tubing. So yeah.
Things quick, kind of the final just difference between the two tube deflections. When I sit on the 1 inch tube, you can see it's not that great. So when I walk over to the 1.5 inch diameter tube and hopefully it'll fall while I'm sitting on it, it's much sturdier. Yeah. So that is our demonstration.
Yeah, manufacturing has been one of our biggest setbacks. We've tried welding. It's really hard, and as you can see, like, our welds aren't that strong right now. We're also trying to figure out how to cut these holes or notch these tubes. And we got these hole saws, but they're just not strong enough right now. So we're gonna try either going slower and using oil with these, or we're gonna mill the notches in the learning factory. So that's where we're at right now with manufacturing.
Thank you.
Thank you.